Hi to all the students. How are you all doing? Come on, let's be in the chat. I can clearly see we have Chris H, we have Genius Yuva, we have Khushi, and we have Raghav P as well. Nobody present here. I need more clarity on the atomic radius part of the last class. Hi Raghav, do not worry. Whatever your doubt is, put it in the chat, okay, for now. And as soon as I'll be starting up the lecture, I'll see your doubt, and I will be telling you how whatever clarity you need. Okay, so for the first time, if there's anybody who's looking at me, hearing my voice, coming onto this channel, subscribe it. Okay, and apart from this, do not forget to share the video, because this is how we will absolutely help other students to know where the quality education is getting given to you. And now over here, guys, pay attention. My name is Luv Mehan. I am a graduate of IISc Bangalore. You should definitely follow me on Unacademy @Luv Mehan. And also, guys, do remember, do not forget to join my Telegram channel, which is Luv Mehan JEE Chemistry, and where you will be getting the PDF of this particular lecture as well. And apart from this, there's one more Telegram channel that you should be joining up. It's a new channel. It's a new Telegram channel where Yavar sir and I am going to be putting up the physics and the chemistry content. And the Telegram channel that we are talking about is JEE English _Unacademy. And you should remember, boys and girls, if there's anybody who's actually preparing for 2021, yes, I'm talking about advance, there is a crash course from my end. And for those who are actually going, learning 2022, any droppers, any freshers for 2022 students, there are a lot of chapters which I have really completed. If we talk about the whole physical chemistry, we have completed the whole physical chemistry. If we talk about even the inorganic chemistry of class 12th, even that is going to get completed by the end of this month. And there are 2 new batches for you guys where everything is taught in English. The name of the batches are Spark batch for 2023 students, Shine batch for 2022 students. You should get enrolled in these batches because these batches are new, and the frequency of English batches is slightly less. So do not miss out these particular batches. If you are looking for, or really thinking to join an academy, maybe within a week or maybe so, do join it right away. And apart from this, you should definitely remember, for 2022 students, there is a U set coming up. This U set is the scholarship test, but only for 2022 students, only for those who are actually taking drop or are also going to appear for 2022 JEE. And pay attention, guys, not for the rank 1, 2 and 3, but for the top ranks, first 1000 ranks. Everybody who's going to achieve, who's going to get a rank between 1 till 1000, each and everybody will be getting up 100% of scholarship. This is amazing. Do go for it, guys. 1000 of the students will be getting up the 100% scholarship. And over here, you should remember that ultimately there would be 90 questions, 180-minute challenge. All the questions are going to be the JEE mains pattern, and attempt and win scholarship up to worth rupees 1.6 crore, which is the pool price of the scholarship. So do remember that. You can actually, whenever you want, take a screenshot, scan this later and register it. While registering, do use the code LOVEGURU to get the enrollment free. And do remember, this has the limited registrations, so be the first one to do it. And apart from this, for droppers, there are an endless number of courses which are floating up for 2022, 22, 22, 22, 22 batches. And what about mine? It's already running. So there are the batches which are actually coming up every month, every week for 2022 and 2023 students. So do not forget to enroll. And for the scholarship, for if there's anybody who wants to get even 25, 50, 75 or 100% scholarship, then do not forget to go for the Unacademy Combat, where the enrollment is again free. To keep every enrollment free, the code which has to be used is going to be LOVEGURU. What is the code? LUVGURU. Every Sunday 11 AM. Do remember that. And apart from this, you should remember, whenever there's any student who comes to Unacademy, each and every student gets the best quality education with best teachers across the nation. And we have India's best educators over here. We have live interactive classes where you can ask your doubts and get them resolved instantaneously. PDFs from the teachers, short notes are available to you guys every course is structured. Live and test quizzes are also available. These are the common features of Plus and Iconic. And do remember one more thing, boys and girls, whenever you go for Iconic, personal coach and study planner, study material, expert guidelines, test analysis, everything is available. So even if you are planning for Plus, you can upgrade to Iconic later as well. For those who are right now into the, in class 11th, I am recommending you 24 months of subscription right now, which is the cheapest if you would compare anywhere. But you should also compare with the people, from the platforms which actually can provide you quality education, not by their words, but by their work. And over here, guys, 50,000 rupees, 50,400 rupees after this discount, 10% off by using up my code. So do remember to use the code. Okay. And yes, now we are diving into the lecture 3. First and the foremost thing that you guys really have to do is mark the attendance. Come on, let's do this and let's start this class. So let's start the class and let's crack. Yes, amazing. Hi to Archak. Sir, one request is chapter ke baad please start 11th organic, so you will, no, don't worry. For the class 11th organic, we are going to revise organic chemistry, let's say the GOC. We'll discuss carbocation, carbon ion, everything, resonance effect, hyperconjugation, everything in the class which is going to happen on Wednesday. Apart from that, we are going to cover isomerism and IUPAC nomenclature in the next class. So I am going to teach you GOC in 2 classes. Apart from this, hydrocarbons will again try to keep it either in 1 class or the 2 class, and then we will cover up the class 11th organic chemistry, because a lot of students in their school organic chemistry has started earlier. So that's the reason I'm going to do it. Okay. Now let's move ahead. This is where we are going to talk about the lecture 3, where we have ultimately till now in lecture 1 and 2 we have actually talked about why there is a need of classification, and now we have looked for the trends as well for the atomic radius. We have also looked for the electronic configuration, which elements are there in S block, P block, F block, D block, and everything. We also talked about the position of hydrogen and helium as well in the previous class. But in today's class, we are going to talk about 3 major factors, which is ionization energy or enthalpy. Enthalpy and energy, are the synonyms. Apart from this, we are going to talk about electron gain enthalpy or electron affinity. And the third, we are going to talk about electronegativity. So do remember all of these, okay? So because why? Because these three things should be known to each and every student who is actually learning chemistry, because the whole inorganic chemistry, even every part of chemistry depends upon these things. The reactivity for any particular element depends upon these 3 things. And yeah, okay, is everybody ready with a pen and paper? And do remember, this class, the theory part will get end soon, but there are going to be endless questions after that. So be prepared for the questions as well. We are going to summarize the chapter with those questions. Be ready. Okay, so let's talk about the ionization enthalpy. What exactly happens, guys? Pay attention. If this is going to be your nucleus, what does nucleus have? The neutrons and the protons, but neutrons are not providing any force of attraction to the electrons. So do we have an electron? Yes. Let's say this is shell number 1. These are 2 electrons, 1s2, and let's say this is shell number 2. There is one more electron with you. Now, do you really think that there is going to be a good force of attraction between the protons and the electron? Yes. But now let me know, when you are holding up something, when you are holding up an ice cream, do you have any favorite flavor of the ice cream? Let me know. So if you are, mine would be coffee, because anyhow somebody would ask. Okay, so now ultimately, if you are actually holding up an ice cream which is favorite to you, is this electron favorite to the protons? Yes. And now if somebody wants to snatch it away and in return isn't giving you anything, obviously they just seriously wants to steal that ice cream from your side. Coffee, butterscotch, amazing. Chocolate and coffee, amazing. So pay attention. Over here, would you resist? If somebody is trying to snatch it away from you, will you try to pull it back? Yes. They are trying to take it away from you, but ultimately when somebody succeeds to snatch away that ice cream from your end, did he or she actually applied a lot of energy? It could be a 2-minute struggle, it could be a 2-second struggle, but there would be some amount of energy which had been applied, correct? This is the energy that we're talking about. So ionization energy is the energy or the enthalpy to remove that electron, but from an atom which is in gaseous state. So whenever we talk about gaseous state, we mean that the atom over here is an isolated one. It should be an atom, okay? It should not be, there shouldn't be any other atoms nearby. And ultimately what we are trying to do over here is we're trying to snatch away this electron. How much energy are we providing to pull this particular electron? And we are making it, we were pulling it so apart that ultimately, if we are talking about, let's say, sodium, okay, we provided energy. What am I making over here? Triangle, okay? What does triangle denotes? Heat or energy, okay? And then sodium became plus, which became an ion, cation plus electron. This electron is way much far than, far from the sodium plus. So now guys, pay attention. Did we get an ion? The process to make an ion, you can remember just like that, ionization, where we are actually putting up energy to pull the electron out. That is going to be the ionization energy, okay? This is a neutral atom. First electron, whenever the first electron had been removed, this particular energy is known as IE1. First ionization energy. What about second ionization energy? Now think about it. Somebody has already snatched your ice cream, but now you were thinking of, okay, it's okay, there's no point of crying now. Let me, the person whosoever snatched away the ice cream would be much in need. Let it be. We can buy more. And you go to the shop and you ask for another ice cream. Now somebody else comes and starts snatching away. Will you resist less or will you resist more? Will you resist less this time? Already few seconds back somebody snatched away your ice cream. When you are having a second ice cream, even somebody again came to snatch it away. Will you resist less or will you resist more? Guys, do let me know. Come on, you'll resist more, obviously, right? So whenever, let's say, we have sodium plus and you are actually applying again energy to make it sodium 2 plus, then what's going to happen? Anyhow, this particular energy is going to be the ionization energy, which is twice. And in such a scenario, as you guys are only saying, you will resist more, right? The person who has to snatch away that ice cream, second ice cream from you, now he or she has to apply more energy because you are resisting more, correct? Similarly, over here in the atom, the protons, the neutrons, the nucleus is resisting more right now. It's not allowing you to take the next electron much easily. Hence, do remember, ionization energy 1 is smaller than ionization energy 2. Then what about the third electron? Ionization energy third is going to be much greater than ionization energy 2, and so on. Even whenever we are removing one electron, progressively, then ultimately the ionization energy for that is going to be higher than the previous ionization energy. Clear? Raghav P is saying, I think I am blocked from the live chat. No, not at all. I can see your chat. Okay. Hi Lakshika. High, very high as compared to the first ionization energy. Amazing, amazing. So this is what we're talking about. What are the units for ionization energy? Pay attention. It's either EV per atom, electron volts per atom for particular atom. When we talk about moles, not one atom, but maybe let's say 6.023 into 10 raised to 23 number of atoms. Then we ultimately dive into kilojoules, not even in joules per mole, kilojoules. And then, in other words, kilocal per mole. Okay, so do remember this. How many of you remember 1 EV is equals to how many joules? Somebody gave me an answer yesterday when we were learning, when we were actually into solution chapter. Come on guys, let me know. What's going to be the answer? Hey Abhi, don't worry, it's okay. you have to give me an answer. Okay, again, 1 EV is equals to how much joules? Let's see. And apart from this, 1 EV over here, we are not converting into kilojoules, we're converting into joules per mole. So we are actually dividing up with the Avogadro number as well. 1.6 into 10 raised power minus 19 joules. Amazing. Okay, amazing. Lakshika OP, Khushi OP, Chris OP, Abhirami, thank you कह रहा, अच्छा ठीक है, अभी OP, ठीक, everybody's OP, okay. Now these are the numbers that you have to remember, ठीक है. If you remember this as well, there's no point of remembering this, because whenever you're converting EV into joules, this is the conversion. Whenever you're converting atom into moles, you know the number, the Avogadro number, correct. And now ultimately this is what we're talking about. So first, in the case of first ionization energy, give me a second, we are talking about, let's say we have an element M, okay, and what we are doing is we are providing ionization energy 1, and then what we are doing is we are having 1 removal of electron. And when we talk about the second ionization energy, it should be, there should be M plus already available, and then this is ionization energy 2, M2 plus 1 more electron. Okay, so do remember that. And now I'm going to ask you something. If I am doing it like this, metal applying some energy and directly making it as M2 plus 2 electrons, what is the value for this triangle delta? Is it ionization energy 2, ionization energy 1, or the sum of both? Let me know. It's your call. Okay, yes, come on boys and girls, let me know. What do you think? Over here we are removing 2 electrons at once. So over here, did you just apply ionization energy 2 to do it, or both? Sum of both? Yes, absolutely correct. So this one is going to be equals to ionization energy 1 plus ionization energy 2. To do that, simple mathematics, simple concept, no need to dive into the definitions as well. Do you want to? It's the same thing, let it be. Okay, now let's talk about the factors affecting the ionization energy. So when we are going to talk about, let's pay attention. Let's say this is sodium, we're talking about sodium over here. This is the nucleus, this is the outermost shell, this is the outermost shell. Let's talk about potassium. Potassium is already bigger than the sodium. As we go down the group, atomic size increases. Okay, and now this electron, oh, what happened, is closer to the nucleus, but this electron is far away from the nucleus. Which one is easy to snatch? Let's say your friend is having a chocolate, your friend sodium is having a chocolate, but he has kept the chocolate very much close to himself. But there is one more friend, potassium, which also has a chocolate, but that chocolate is a bit far away from the potassium. Which one is easier to snatch away? Which one is easier to just simply, steal it? Because ultimately, see, stealing is a bad thing, but when it comes to ionization energy, one atom steals the other's electron, right? So can't help it. Let me know over here. If there is less nuclear force of attraction to the valence electrons, the ionization energy will be less. Amazing. So over here in this case, obviously the electron, the outermost electron of potassium, to snatch it away, we will require less energy because it is far away from the nucleus, correct? Over here the ionization energy is going to be less. So for potassium, whatever ionization energy 1 we are talking about, and for the sodium, whatever ionization energy 1 you're talking about, you should remember this one is going to be more than the potassium ones. So ultimately, as the size increases, ionization energy decreases. Okay, as the size increases, atomic radius, inversely proportional, atomic size, ionization energy or potential, same thing, ionization energy decreases. So do this, arrows, I always do that. Cool, Amazing. Let's move ahead. Are there more factors? Yes. Let's talk about the nuclear charge. So now guys, we will talk about something. Let's pay attention. So from lithium, let's compare lithium and let's compare fluorine. What are we talking about? We are actually talking about across the period. This one was where down the group it was easy. Even we can do this across a period as well, because when fluorine has smaller size than lithium, size is smaller, ionization energy is going to be higher. But now let's use lithium and fluorine as an example when we are talking about nuclear charge. Pay attention. How many protons does lithium has? How many? 3. How many protons does fluorine has? 9. And hence, this is lithium. I'm trying to make fluorine smaller as well, because as we go across a period, atomic radius decreases. But over here, as you see the number of protons increasing, what is exactly going to happen? Over here, the nuclear charge is increasing, correct? And screening effect remains almost similar. So now, let me know. Yes, the correct answer to this question is fluorine, where the number of protons are more, their ionization energy is going to be more. If you are stronger and somebody comes up to snatch away the ice cream from you, if you are stronger, it would be hard for the other person to snatch it away. That's what ionization energy is directly proportional to the nuclear charge. Do remember that, okay? And now let's talk about something else. Over here we're talking about the screening effect. How many of you know what is a screening effect? I'll tell you something first, okay? Whenever we talk about the screening effect, this is provided by electrons. Electrons provide this. Do remember, electrons of s orbital subshell provides best screening, than p, than d, and than f. These two provides very poor, these two provides very strong, okay? And s is going to have the best screening effect. And now let's talk about this, okay? So what is exactly the screening effect? Because you know what, I'm not going to take an extra class to teach you this. Now let's pay attention. How many of you ever have gone to a picnic? Yeah, I can understand. From past 1.5 2 years, nobody has gone to the picnic with your school friends and the school faculty and teachers. But now let's think of 3 to 4 years ago. I'm pretty much sure everybody would have gone to a picnic once or the other day, right? So now guys, pay attention. Over here, what are we really talking about? Let's say this is the spot where your teachers are sitting and they just took you to a very boring park, okay? And in this park, what is exactly going to happen is there are some swings, but the teachers tell you that do not go much far, okay? But why the kids are there? Simply to roam, simply to have fun. Now let me ask you something. If this is where all the teachers are sitting in the middle of the ground and they're trying to keep an eye on you, and there are more bushes. So in this scenario, would the students be much far? These are the students. Or in another scenario, I'm asking you something, okay? If this is the spot where teachers are sitting and there are very less bushes. In which scenario do you think these not the electrons, but these hollow circles, in which particular position, in which particular option do you think that the students will be able to go much far? I personally believe wherever there is going to be much more space to hide, or wherever there is going to be an obstacle where teachers cannot see through, there the students will have more liberty to roam much more far away. Or maybe let's say there are trees as well. है ना? So this is what we're talking about. But wherever these obstacles are going to be less, so what will teacher do? As soon as the electron slightly this particular student is slightly trying to go a bit far. The PT teacher, always there with a whistle, maybe a football one, just putting up a quick whistle and to just show you the hand and bringing you back. Correct? So this exactly happens with the screening effect. Now these trees, which provides better screening? Which is a better cover? A small bush or a tree? Let me know. If your answer is a tree is a better cover rather than a small bush, then ultimately you are on track. These bigger trees, these trees are going to be the S electrons. These small bushes are going to be the P electrons. Then what about D and F? D electron is something, D subshell D electrons is something like if you are actually trying to hide behind a rabbit. Okay? If you're actually trying to hide behind a rabbit and you think nobody is watching you. And F electrons could be like if you are actually trying to hide behind a mouse. Okay, so that's how it is. Okay, so do remember that. Okay, so do remember that. So ultimately I am not going to remove any of this. So do remember, whenever the screening effect is going to be better, wherever the screening effect is going to be better, that means there are so many trees and bushes, these electrons will be able to go slightly far away, and as soon as the electron went far, it's easy to kidnap the electron. It's easy to kidnap the electron, correct? And this is where it will take lesser energy to kidnap the electron. Ionization energy is going to be lesser when there would be screening or shielding. Okay, so do remember this. Is this clear? Hiding behind the mouse. Yeah, obviously. I mean, you have to actually look for cover, which is a better cover. Even we can actually assume different level of curtains as well. So, for me, S block, not the S block, S electrons are the electrons which provide the best shielding. It's a very thick cloth. So thick that the sunlight is not passing through. And nobody will, if I put this cloth, in the middle of a, room, nobody will be able to see me if I am standing there. So this is where I'll have more liberty to roam freely. Something like that. We can take any type of example. I think this tree, bush, rabbit and mouse wala example is actually very much funny. Correct? So do remember that. So this is what it is. Whenever the screening effect increases, ionization energy decreases is what you have to remember. Cool? And now let's talk about the screening effect as well. As we go down the group, screening effect or shielding effect decreases. And as we go from the left to right across a period, I'm going to do it over here, across a period, does screening effect increases or decreases? Screening effect is majorly because of the inner electrons. Majorly. Outer, the valence shell electrons also provide screening effect, but you should remember inner electrons as well. And when we talk about lithium till fluorine, from lithium till fluorine, the inner electrons are only 2. 1s2 in the case of lithium, and in the case of fluorine as well, 1s2. So do remember that. Okay, screening effect remains almost same from lithium to fluorine. The only thing that changes is effective nuclear charge increases. Do remember that. And when we go, from the top to bottom, Z effective value decreases. So do remember this. Effective nuclear charge decreases. And what is the formula for effective nuclear charge? Pay attention. Z effective is equals to the total number of protons, which is the total nuclear charge, minus the screening constant. Okay, this is this sigma value depends upon how much is the screening effect. If the screening effect is more, Z effective value, if the screening effect becomes more, Z effective value decreases. So do remember that as well. This comes under Slater's rule. Am I going to teach you Slater's rule? Yes. In this class? No. I'll be taking up a different class 2 minute or 5 minutes extra class for you guys to give you this one, because to be very honest, the weightage of Slater's rule, it really doesn't come in JEE. I don't know, it's still there in the syllabus, it really doesn't come, so do not worry about this. And now let's talk about the penetrating effect. When we talk about the penetrating effect, the trend is the same. When we talk about the S orbitals, P, D and F, S has the best penetrating effect. And do remember this, whenever we have higher penetrating effect, higher is the ionization energy. Now you know how to remember or how to make it easy for you to remember the penetrating effect. Think of the shape of the orbitals. Now pay attention. So whenever we compare the S, is this the S orbital? S subshell? Yes, correct. What about the P, Px, Py, Pz? Now this one over here, guys, is 2S and this one over here is 2P, 2Px, okay? Now pay attention. Where is going to be the nucleus? Here in the middle. Where is going to be the nucleus in this case? Here in the middle, okay? Now pay attention. In which scenario, if the electron is available in 2s and 2p, in which scenario do you think it's far away from the nucleus? In which scenario do you think the electron is far away from the nucleus whenever it is revolving around the nucleus? Is it going to be the 2s or the 2p? You know the location of the nucleus right now, and you know that over here till here the electrons will be available, over here till here the electron is going to be available. Think about it. I'll look into the so what's your favorite color? My favorite color, see, apart from purple, I would say every color is favorite, though these days I really like red. Apart from that, I really like, yeah, red is good. I'm bored of blue now, red is good. But the color which I actually hate, I don't hate any color other than purple. Okay, chalo, come on over here, boys and girls, let me know, in which scenario do you think the electron is slightly, very minutely far away from the nucleus? It's 2p. Hence, the penetrating effect is less. Penetrating effect means the electrons are, if the electrons in the S are much more closer to the nucleus, they are kind of penetrating inside the atom. But in the case of P, they are not so penetrating. They are slightly outside. In the case of D, slightly outside. In the case of F, slightly outside. So that's the case. Okay. So do remember that. That's the reason S has more penetrating effect. Very minutely you can think of, they are very much closer, not very much, but yeah, closer to the nucleus. Then we have P, D and F. And higher the penetrating effect, if the electrons are closer to the nucleus, it will be hard for you to snatch it away. Correct? And that's what it is. If the penetrating effect increases, the ionization enthalpy increases. Is this clear? Come on, boys and girls, is this really clear to each and everybody? If yes, give me a smiley in the chat. And now, yes, amazing, Lakshika. And now let's talk about the electronic configuration which provides you so-called exceptions. And is there any exception? No. Exception is actually a word for noob students. Exception is a word for noob students who really do not know anything about chemistry, who really do not know about two things, which is electronic configuration. See, majorly all the exceptions in, I would say, organic chemistry or this inorganic chemistry or whatever we are learning over here right now, the trends and all, is because of two things. The first and the foremost thing is the electronic configuration, and almost 70 to 80% of the exceptions, if you know the electronic configuration, will never be an exception. Second, if electronic configuration is not the answer, then the second answer is going to be the atomic radius or atomic size. So do remember this, these two. And now over here, whenever we talk about the electronic configuration, let's take some examples. Over here, guys, pay attention. Whenever we're talking about nitrogen, what is the electronic configuration for nitrogen? It is 1s2, that is helium, 2s2 and then 2p3. I'm going to make these 3 electrons over here. Okay, this is 2p, 1, 2, 3. Okay, and now I'm making up oxygen. 1s2, 2s2, 2p4. Hund's rule complete. Then we can start with the pairing, correct? So this is 2p4. Now, which electronic configuration according to you is much more stable? Which one of these electronic configuration is much more stable? Do you see something like a fully filled or a half filled subshell? This nitrogen's p subshell is half filled. See, fully filled, half filled. Fully filled and half filled subshells are very much stable. Now pay attention. Fully filled, neither half filled, neither fully filled. And then in the case of oxygen, the electronic configuration is slightly on the unstable side. And ultimately you should remember, whenever you are trying to snatch away an electron and make it n plus electron, this n plus will be having an electronic configuration which is 1s2, 2s2, 2p2. Now which is more stable? 2p2 is more stable, or when you are trying to go with oxygen, making it O plus, removing an electron, and oxygen will be having the electronic configuration 1s2, 2s2, 2p3. Did we actually help oxygen to get a stable electronic configuration? Yes. Oxygen's electronic configuration was not that stable. It was 2p4. We helped oxygen to make it 2p3. Is oxygen going to be grateful to us? Yes or no? I think yes. This is where oxygen is going to resist less. But then if it is grateful, then why will this oxygen will resist? Because protons don't understand electronic configurations. Protons simply wants their electron. Okay, na? But electrons know their electronic configuration. Where the repulsion is more, where the exchange energy is less or something. But when we talk about nitrogen, did we help nitrogen by removal of this electron? No. Nitrogen was at much better position, much better condition. But when we have removed electron of nitrogen, 2p2 configuration is of no use to nitrogen. Correct? And that's the only reason oxygen is going to resist less, but nitrogen is going to resist more, and hence ionization energy of nitrogen is greater than ionization energy of oxygen. I made O too big. Give me a second. Though, if you would remember, oxygen is more electronegative than nitrogen, but still, in the case of ionization energy, it's much more easier to remove an electron from oxygen. Only and only because of the electronic configuration. Clear? Yes, let's move ahead. And this is where we are coming closer and closer to complete this chapter. And now we will talk about the factors. Okay, now guys, pay attention. On the left hand side, on the y-axis, you see the energy. How much energy? Now what you should really know about these elements and the graph. Guys, pay attention. Whenever we talk about the noble gases, they're exactly at the peak. They're actually having the position at the peak. Why is that? In their own period, see guys, period, hydrogen, helium, then lithium, beryllium, boron. Oh, beryllium and boron is also having some anomaly. We'll talk about it. Okay? Then ultimately boron, carbon, then over here we have nitrogen, carbon would be here somewhere. Okay? And then nitrogen, oxygen, fluorine would be somewhere here, and then we have neon. So all the noble gases are actually occupying the peak. And why is that? Because their electronic configuration is the only answer. Their electronic configuration is absolutely stable. They will be having NS2 and NS2 and NP6 electronic configuration. The graph is like a heartbeat rate. Yes. So will you provide the notes in the Telegram channel of the YT channel? Yes, I'll be doing that. And now guys, by the way, hit the like button if you're liking the class. And now over here guys, pay attention. When we talk about the least amount of ionization energy, the alkali metals, group 1 elements, S block elements, group 1 elements, right? Do remember this, okay? It will be really good for you. And now ultimately whenever we talk about the anomalies like nitrogen, oxygen, beryllium, boron. Let's talk about beryllium and boron as well. Whenever we talk about beryllium, the electronic configuration is 1s2, 2s2. Wow, 2s2 is fully filled. But when we talk about boron, 1s2, 2s2, 2p1. Is 2p1 half filled or fully filled? No. But what if we remove the electron, this 2p1 electron, and make the electronic configuration of boron plus as 1s2, 2s2, 2p0? Is it a good one? Yes, because 2p1 is not providing any type of stability. But when we talk about the removal of electron from 2s, 2, then ultimately there's no point of having 2s1. Beryllium is going to resist more, boron will resist less, and that's the reason the ionization energy of boron is less, and for the beryllium it's more. Do remember this. Clear? And I'm going to ask you one more thing. Guys, one more thing. Over here we will talk about sodium, magnesium and aluminium as well. Same like beryllium and boron. Aluminium's 3s2, 3p1 is of no use. I mean, obviously it will be of use, but still I'm just saying. Magnesium 3s2, that's much more stable than 3s2, 3p1. Same scenario, electronic configuration is the answer. Do remember this. Okay, and now over here in a period, whenever we talk about in a period, across a period, ionization energy in general, ionization energy increases. Some exceptions, nitrogen, oxygen, but are there really exceptions? Should you call exception? No. None of my students should remember a name exception. Though I might say it to you just to grab your attention, but I'll always be giving you an answer to it. I'll always give you the logic behind it. Okay? Good. And now in a group, down the group, ionization energy decreases. Increases, decreases. Do remember this. You know what? I'll tell you a very good fact. Everything, whatever decreases down the group, increases across a period. Whatever increases across a period, decreases down the group. But there's only one thing which increases across a period and increases, down the group as well. And what is that? I'll tell you. Okay, let's take another example. If you talk about size decreases and down the group size increases. Correct? It's always opposite. Whatever is happening across a period and down the group. Then what is this one thing which increases down the group and increases across a period as well? Just one thing. Let's see. Yes, Abhi, you have to tell me. Come on, let me know, boys and girls. And it is only and only the... Come on, boys and girls, I want to give you an answer, but come on, don't give my name. There's no point of giving my name over here in the chat. Come on, let me know. What is this one particular thing which increases across a period and increases down the group as well? Come on. We'll call it special case. Even you, ठीक है, special case. Okay. You don't wanna, even you can tell me, sir, we don't know. I'll move forward. And the correct answer to this question is only and only atomic number or the number of protons. Yes, Raghav is the first one giving me the answer. Then we have Ria, and yes, other students would be giving me the answers now. Atomic number is the only thing. From lithium to fluorine, 3 till 9. From sodium till or lithium till cesium, you know the trend. Correct? You can use the magic numbers. So now, ultimately, this is how it is. Whenever we're talking about in a period, so hydrogen and then helium. Why is that so high? Noble gas. Then we have lithium, beryllium, boron. Why is this? Then nitrogen, oxygen. Why is it? Right? And then we have neon at the top. So it's the same thing that I have been telling you. And now let's talk about electron gain enthalpy. Electron gain enthalpy by its name tells you about everything. So how is it? Assume there is an atom over here, neutral gaseous atom or isolated one. So now guys, pay attention. If this is fluorine right now and this is chlorine right now, okay, let me know something. How many valence electrons are there in the case of fluorine and chlorine? Same, 7. We'll make this 1, 2, 3, 4, 5, 6, 7. I tried to make the electrons not much far away from the fluorine, I mean from the nucleus, where F I have written, that's the nucleus. When we are talking about chlorine, how many? 7 again, but I'm making it more far away from the nucleus. 1, 2, 3, 4, 5, 6, 7. I'm pretty much sure you guys are able to see the difference. And now guys, pay attention. If I'm trying to feed this electron to the fluorine, will fluorine accept this electron? According to the electronic configuration, fluorine should accept this electron. And why is that? Because fluorine from 1s2, 2s2, 2p5, it will become 2p6. A noble gas configuration. Amazing. Similarly with the chlorine, 3s2, 3p5 will become 3s2, 3p6. So for both, accepting an electron is not a problem. For both, accepting an electron is not a problem. But now we'll see where the problem lies. And now ultimately guys, do remember one thing. I'm just going to remove this. Both of them are capable of becoming fluorine minus. Okay. And what's going to be the scenario? There will be 8 electrons, right? 1, 2, 3, 4, 5, 6, 7 and 8. If you would see, I tried making the size bigger as well, because I taught you in the previous class the size of the anion is greater than the size of the neutral atom. And now I'll make it for the chlorine as well. I need more space. If I'm trying to provide extra electron to the chlorine minus is going to be the one anion. But now one, two, three, 4, 5, 6, 7, 8. 1, 3, 4, 5, 6, 7, 8. Okay. Yes. Now anyhow, chlorine minus looks much more bigger than the fluorine minus. Correct? Where do you think the inter-electronic repulsion? Inter-electronic means inter means between, electronic means electron. Between electron, where do you think the repulsions are going to be more? Where electrons are much closer to each other or where electrons are far away from each other? Think about it. Think of you are with some people, some classmates which you do not like. If they are sitting around you, will you be more repulsive? Or I'm so sorry, I'm not saying you should be repulsive to anybody else. Electrons do that, so I just have to give you some human-like example. And when we talk about, when they are slightly far away from each other, so do you think in which scenario repulsions would be less or more? Let me know. In the case of fluorine, where the electrons are close, inter-electronic repulsions are more, right? So I'm going to write this over there. In fluorine minus, inter-electronic repulsions are more. So now guys, tell me one thing. Is this electron and this electron same? The answer should be yes. Electron is same. Okay. Now let me ask you something again. Where do you think the extra added electron? Where do you think the extra added electron is much more happy? What did this electron wanted? Why the hell this electron is going to the fluorine or chlorine? You know what should be the answer? Because this electron has affinity towards, love towards protons. Where are the protons? Same for this electron as well. So electron was in the need of protons. But now ultimately this is the extra electron, let's say, and this is the extra electron. Where do you think this electron is actually feeling much more happy? It's actually in the case of chlorine. Why? Because this electron is getting the love from the protons, the attraction from the protons, even for the same. But ultimately over here, they're pushing more. These electrons are pushing more. Over here, these electrons are pushing, but less. So ultimately, where do you think electron is going to be much more happy? In the case of chlorine. Happier the electron. Why in this world anybody could be happy? Guys, pay attention. To be happy, you have to be stable, right? Everybody likes stability, correct? To be stable, you should have energy which is less. When this electron became happy, it's all because of the electron feeling stable. And as soon as something feels much more stable, the energy has to be reduced. The energy over there of the system has to reduce. And over here, when we talk about chlorine minus, give me a second.
From pavilion X360.
Okay. So now, give me a second, boys and girls. Over here, what are we really talking about? Whenever we are actually having chlorine and giving it an electron and making it chlorine minus, which is having higher energy. Think about it. I told you, when this electron is accepted over here, everything is happy over here. Where is the more energy? There it is going to be more energy. Here it is going to be less energy. Delta H, it's going to be final enthalpy, final energy minus initial energy. Final is lesser, initial is more. Delta H of this particular reaction is negative. And whenever it is negative, it is exothermic. Good one, Khushi. So now think about this. Now ultimately, if I'm making fluorine minus, no, not fluorine minus, fluorine plus electron, making it fluorine minus, is this happy or this is happy? Still this is happy, okay? But I'll try to reduce the happiness because it is not happy as fluorine minus, okay? This is more happy, this is slightly less happy. And now again in this case, delta H is going to be negative. Which value is going to be more negative? This one or this one? This value will be more negative. I'll show you the example. Okay? So we have the data. It's all done experimentally. Whenever we talk about fluorine and chlorine, whenever we provide them an extra electron, the amount of energy which is removed is minus. Minus tells you removal. Minus tells you the heat has been liberated from the system to the surrounding. 349, that is the delta H value. And when we talk about the case of fluorine, it is also minus, but 328. Where do you think that the energy has been released more? A lot of students think minus 349 is a smaller number than minus 328, which is mathematically correct. But you should remember the loss of energy which is higher is in the case of 349. Minus sign simply tells you what exactly happened with energy. Is it coming out of the system or going inside the system? Do remember that. Okay. So because I asked a student and he said, sir, minus 349 is a smaller number. Don't get confused with that. So now, what is then, what if you are able to see what is this Eg? Delta H for electron gain. So that becomes electron gain enthalpy. H stands for enthalpy. Electron gain enthalpy values. Whenever we are going to look for the electron gain enthalpy values for which ones? By the way, give me a second. Yes. Whenever we talk about the group 18 elements, the noble gases, the electron gain enthalpy value comes out to be positive. What does that mean? That means whenever we are trying to provide helium an extra electron, helium says, in order to become helium plus, I will not do that. Do whatever you want. When your friend comes to your party, and because of that friend, you order extra pizzas, and that friend lately starts, saying, I am done. I don't know what to do with the extra pizzas, and he's not eating. And you were like, that you were the only one who said, I'll eat 5 pizzas. Bring it on. Hai na? But now after eating one, he's like, I'm done. What will you do with the next pizza slice to him? Similar is the one thing that you are trying to do with the helium. We're actually forcing helium. You tried giving helium an electron, but when it refused, what will you do? You'll force it, right? You have to eat it. You have to eat it. That's what is going to happen over here. So ultimately, in order to provide helium and electron, we have to provide energy. And whenever we are providing energy, guys, on the y-axis I'm making energy. This is helium's energy. Okay, this much. When you provide an extra electron, helium will already will become unstable. That's the only reason he doesn't want to eat an electron. So helium minus will have higher energy. That's the only reason helium by its own doesn't want to become helium minus. But if you provide this much energy gap, then will helium minus will form? Yes. So ultimately you provide the energy. You provide energy. And this becomes, for noble gases to gain electron, that becomes the endothermic process. That's the only reason positive sign is seen. We have to provide energy. Okay? Do remember this. Is this clear? Stuff it in the mouth. Yeah. चलो ठीक है ना. अभी ध्यान दो अभी यहाँ पे, ठीक है ना. I mean, I'm not talking to Abhi. I'm saying now let's focus on what we are doing. And when we talk about oxygen, minus 141 or minus 200, where do you think the extra electron would be more stable, would be more happy? It should be in the case of sulfur, just the way we saw the chlorine. Correct? You should remember the trends as well. These trends come in the examination hall. So over here for the electron gain enthalpy, so in the case of delta EGH, so do remember chlorine in the case of group 17 is having the highest value, then fluorine, then we have bromine, which is slightly lesser than fluorine, okay, and then iodine. Do write this trend in your notebook. And now whenever we are talking about oxygen, sulfur and selenium, so what do you see over here? Sulfur is having the highest value, then we have selenium, and then we have oxygen. Do remember this. Cool? Yes? Amazing. So now, and what about the group 1 elements? Whenever you're trying to provide them electron, they are like, ठीक है, you can give me an electron, but there's no point. For fluorine it becomes 2p6, for chlorine it becomes 3p6. But sodium and potassium and the rubidium and cesium says, what will we do with the ns2 electronic configuration? That doesn't make us very much stable. So that's the reason they take electron, but they also accept it, but that electron is not super happy. It's okayish. So do remember that. So what about when we go from across a period? Does electron gain enthalpy increases? Does electron affinity increases? So as we go across a period, delta EGH value increases, is what you have to remember in general. In general. Okay? Do remember that. Clear? Amazing. And now let's talk about, yes, in a period, electron gain enthalpy increases. Down the group, what it should be? Down the group, it should decrease. It didn't happen in group 17, all because of the extra small size of fluorine, higher inter-electronic repulsions. But after chlorine, just see 349, 325, 295, 270. It is decreasing, right? So do remember this. 60, 53, 48, 47, 46. It's decreasing. 200, 195, 190, 174. It's decreasing. So delta EGH value decreases. Okay? Do remember this. And now we are moving on to electronegativity. Electronegativity, guys, pay attention. Electron affinity love towards electron is not equals to electronegativity. These are two different terms. These are two different terms. They have to be defined in two different ways. Electronegativity, whenever we talk about, is equals to tug of war. How many of you know what is this? What tug of war is? What type of sport is it? So it's like, let's say there are four men standing over here. There are also four men or women, I mean, you know, standing over here, and they all are actually holding up a rope. And ultimately, everybody is pulling. Everybody is pulling. Let's see who is the strongest one to pull an electron. We cannot talk about electronegativity if we are talking about one atom. Whenever we talk about just one atom, we can always talk about how happy that particular atom can keep that electron. If you are going to get married to a girl, and then you know what are their parents going to say? Will you be able to keep our daughter happy? That's what electron affinity is all about. But when we are talking about electronegativity, it's the war. Okay? It could be a war between you and your spouse. Okay? But what I'm saying is, who wins? If this is an electron, who keeps electrons much more closer is what we're talking about. Okay? Let's take an example. So over here, whenever we talk about fluorine, whenever we talk about hydrogen, what are they doing over here? They're trying to make a covalent bond. In the covalent bond, it's a sharing. So ultimately, this is the electron of hydrogen. This is the electron of fluorine. Though fluorines have more electron, but it only provides one electron for sharing. Now what is going to happen? This electron of hydrogen is going to be way much closer. It's going to be, you can, you know, diagrammatically you can make it like this. This is the electron of fluorine. This is the electron of hydrogen. And this is where hydrogen is. Who's having the electrons closer? Fluorine. And why is that? Because fluorine is much more electronegative. Why is that? All because of the effective nuclear charge, the size, and a lot of things that we are going to talk about. Okay? And now pay attention. Over here, this is the tug of war where fluorine wins and hydrogen has the electrons as well, but it's far away from the hydrogen. But when we talk about, how much far are they with fluorine? It's less. So do remember this. Now let's see over here. The tendency of a bonded atom means it has to be a molecule or maybe, ionic compound, something like that. It is not alone. Okay? Attract the shared pair of electrons towards itself. Electronegativity has no unit. So do remember this. Does electron affinity has unit? Electron affinity is nothing but electron gain enthalpy. Yes, it has unit, right? The kilojoules per mole EV per atom. Does ionization energy has unit? Yes, EV per atom, kilojoules per mole. Does electronegativity has unit? No unit. Okay, it's just a comparison. How stronger you are, how stronger genius you are is when compared to love, sir. You guys can say double. What double? I mean, what? How are we just simply measuring? No, it's a simple comparison. It's relative. There's no actual value. Electron affinity values are actual values. Ionization energy is an actual value. But electronegativity, it's not an actual value. It's a comparison. It's a relative thing. And now, over here, you should remember these values. Each and every student of mine does remember this. Fluorine, oxygen, nitrogen, carbon, boron, beryllium, lithium. Pay attention. What are the values? I'm writing it over here, 4, and now subtract 0.5. Do it in your book. Do it in your notebook, okay? Then 3, 2.5, 2.0, 1.5, 1. See, just 0.5 decrement. Let's talk about hydrogen. In a lot of book, it's 2.2 as well, or in some sources, it's 2.1 as well. You can remember any 2.1. When we talk about sodium, is sodium going to be more electropositive or less electropositive? Because size is increasing. It's going to be less electropositive or less electronegative. Okay, so this is 1. Sodium becomes more electropositive, which becomes a 0.9. Then potassium 0.8. Then rubidium 0.8, cesium 0.7. See a 0.7 difference. Let's talk about the group 17, chlorine, bromine, iodine. Don't go with the scale, okay? So now over here guys, pay attention. Whenever we're talking about chlorine, it is somewhere around 3.3, 3.2, okay? When we talk about bromine, it is having the same amount of electronegativity as nitrogen in numbers, so it is going to be 3. And when we talk about in the case of iodine, it is somewhere around 2.6, 2.7. Do remember that, okay? And now let's talk about few more elements. Not all. Below beryllium we have magnesium, which is going to be more electronegative than sodium. We'll talk about each and everything. Just remember the values. 1.2, because see, when we go across a period, electron affinity increases. The element becomes more loving to the electron, and when we go across a period, it becomes tough to remove an electron. So hence, the electron pulling tendency is more when we go left to right. So from sodium, it's becoming more, 1.2. When we talk about aluminium, it's somewhere around 1.5, right? So do remember these. You should know this much. You should know, all the electronegativities of group 1, all the electronegativities of group 2 or group 17, all the electronegativities of period number 2, and few more when it comes to period number 3. If you know this, it's good. Hi Ahmed, amazing, you're here. Yes, long time, but where were you? Because I have been there on YouTube for long. Acha, so guys, is this clear? How many of you have written this down? Let me know in the chat. And now over here, boys and girls, there is a particular formula. So whenever you're trying to calculate the electronegativity between two particular elements, because obviously it is a comparison. What's the formula? How much? This is because of the arithmetic mean, okay? So this is like how much energy will it require to break hydrogen-hydrogen bond. Let's talk about hydrogen and fluorine. Hydrogen-hydrogen bond. If next B is fluorine, how much energy will it require to break fluorine-fluorine bond? Add them up, subtract it. What does it becomes? This becomes the arithmetic mean, average. And then you again try to break the hydrogen-fluorine bond, and then take the difference of the bond dissociation enthalpy of hydrogen-fluorine and the arithmetic mean that you have taken for the molecules. And then after that difference, take an under root. And then after that, multiplied by 0.208. And then you'll get the answer. Okay. So do you have to really remember this one? Not really. But can a question be there on this? Yes. The frequency is less, but a question had been there in 2019 in the case of JEE. So do remember this, boys and girls. Okay. So did we have to note down this Pauling scale formula? Yes, Raghav, you have to do it. Do remember this, okay? And now, these are the values that I was actually trying to make you remember. There will be slight changes, okay? Like, I'll tell you something. No change in the case of period number 2. No change in the case of period number 3. But yeah, over here, this one is slightly wrong. I don't know why books, but see, anyhow, these shouldn't be perfect values. Even if somebody wants to remember 3, they can do it. But more or less, it's 3.2, 3.3ish. Okay, so I'm going to just write it over there. 3.2, 3.3. In a lot of books as well. Even if you remember 3, no problem. And when we talk about, yes, fluorine, chlorine, bromine, iodine, it's more like 3 actually. It's more like 2.7. So yeah, whichever you would like to remember, it's fine. But do not ever remember a wrong information, a wrong electronegative value from lithium till fluorine. Just do remember that. It's the most easiest one. Do not do a blunder over here. And now, over here in a period, electronegativity increases because I'll talk about this. Electronegativity increases all because of size decreases Z effective value increases. Yes or no? These are the two things that you have to remember. And ultimately, when we talk about the fluorine and all, anyhow, it clearly shows because of the electronic configuration. And when we talk about down the group, electronegativity decreases, but also electropositivity increases. Electropositivity means if the electron is going, they won't cry. That's how it is. You can know electropositivity increases. Why? Because size increases. That is the biggest reason that you should remember. Because the size of the atom is increasing. So do remember this. Anything else? Chemical bonding. We are starting up the chemical bonding from Wednesday. So Wednesday, and I'll make sure that these classes, these chemical bonding also, I mean, it's not as small as the periodic table. I'll take somewhere around 4 classes for sure. I'll try to avoid taking up the 5th class, but yes, 4 classes would be there. Abhi, you're most welcome to do anything. Don't ask. Okay. And yeah, now over here, the electronegativity depends upon the nature of the bonded atoms. And now we saw it, right? How much tough it is to break hydrogen-hydrogen bond, the fluorine-fluorine bond, and the hydrogen-fluorine bond. The atomic sizes, the nuclear charge, how many protons are there. When we talk about hydrogen and fluorine, in the case of fluorine, there are 9 protons. In the case of hydrogen, there is 1 proton. Where would the electron go? Much closer to the one which is having more protons. But now don't do it in the case of sodium and fluorine. Okay. Now in the case of sodium, they have 11 protons. In the case of fluorine, there are 9 protons. Now don't say that the electron will go over here. And why is that? Because you should remember atomic size is a key factor as well. Okay, just simply do not go blindly and follow nuclear charge. Because wherever the size is going to be smaller, the electronegativity is going to be higher. And in both the scenarios, which is more smaller? Size when we talk about the fluorine and the size when we talk about the sodium, it's like this. Okay, so do remember that. And ultimately, we are absolutely at the summary part where you will be able to see a mind map. Guys, do you like the mind map? If yes, give me some smileys in the chat. We'll go through it. So whenever we're talking about the chemical periodicity, refers to the trends in properties. When we go down the group across a period, why boron and aluminium has similar reactivity towards oxide, why fluorine chlorine behaves similar, something like that, है ना? So anyhow, don't worry. I have actually created this whole mind map so that it becomes easier for you whenever you go through the notes. I'm not going to summarize this. This has the whole summary of the periodic table as a chapter. If there's anybody who has actually missed the previous classes, do check it out. But now we are diving into the questions, and the questions are going to be back to back. If there's any student who's scared of the questions, this is probably the time where you are going to leave the class. But ultimately, the one who is afraid of questions will never be able to crack the examination. So remove this fear and solve the questions with me. Let's move ahead. Now over here, the size of the isoelectronic species, size of chlorine minus, argon and calcium 2+. What do you think is going to be the correct answer? But you should remember, what is the atomic number of argon? 18, 17, 18 and then 20. Removal of 2 electrons, number of electrons becomes 18. These are the protons. Number of electrons are 18 and number of electrons are 18. Now what do you think? The size of these isoelectronic species, how is it going to be? I'll do it for you guys. Chlorine minus will have higher size than argon, and calcium 2+ will have smaller size. And why is that going to happen? All because of the number of protons to the number of electrons ratio. Its number of electrons are more than the number of protons. Number of electrons are same as number of protons. Number of electrons are less than the number of protons. Over here, as the number of electrons are decreasing, the inter-electronic repulsions will decrease as well. Yes. Over here also you should remember the one full shell, the third shell has been removed. We are actually increasing the inter-electronic repulsions, right? But everything, see, these repulsions and all can be balanced by the total nuclear charge. So it clearly depends upon, because these things are same. Inter-electronic repulsions is same. What do you see? What is the difference? 17, 18 and 20 protons. And the correct answer to this question is going to be the nuclear charge. D is going to be the correct answer, because the number of protons are the sole reason for the nuclear charge, correct? And now let's talk about the next one. Let's talk about the next one. The IUPAC symbol for the element with an atomic number 119. The IUPAC symbol is what we're talking about. Do you remember the nomenclature rules? Un stands for un stands for one. Un, and what's for 9? Come on, let me know. See, first of all, when you see 1, you should remember the symbol should have first two letters which should be same. UN, UU could be, UU could be, UN no. And for 9, it should be N, correct? And over here, you should remember, over here, give me a second. Yes, the correct answer to this question is going to be having E, because it's N. Okay, na? You should remember that. Un, N. Do remember this. Don't get confused. Okay? Yes or no? Cool. The genius Yuva. B is the correct answer over here. UUE, not UUN. Amazing. And now let's move towards the next one. The element having greatest difference between the first and the second ionization energy. First and the second ionization energy. I mean, that means the first one could be way much easier to remove, the first electron, and the second electron is tough to remove. Or maybe removal of first electron is too much tough, but the second removal is too much easier. Which particular elements would show this kind of thing? And ultimately, the correct answer to this question is going to be the D. Why is that? Because whenever we talk about group 1 elements, they have an electronic configuration which is NS1, but also before that there will be a noble gas. Okay, a noble gas configuration. Whenever you remove one electron, so it is going to be just the noble gas configuration. And whenever you're trying to remove one more electron, so this is ionization energy 1, where things becomes much more happy because of the noble gas configuration. But if you are trying to remove one more electron, ionization energy 2, the electronic configuration makes the element angry, correct? So it's easier to remove the first electron. That's the case of sodium, potassium, rubidium, lithium, cesium, right? But when it comes to removal of second electron, they resist because of the electronic configuration like neon for sodium plus and so on. Potassium, for potassium plus it is argon. So do remember this, right? Yes or no? Cool. And now pay attention. Whenever we're talking about the group number, the number of valence electrons and the valency of the element with an atomic number 15 respectively are. The group number, first group number, guys, don't get confused. First of all, tell me the group number, then the valence electrons, number of valence electrons, how many there are in the outermost shell, and then the valency, to how many elements it can actually directly attach to. So now let's see the correct answer. So over here with an atomic number 15, so who is having the atomic number 15? Till neon it's 10, right? Till magnesium it's 12, aluminium becomes 13, silicon becomes 14, and phosphorus becomes 15, correct? So we are actually talking about phosphorus. So this is where I always tell you that the atomic number should be remembered. It should be remembered in your brain. Are we talking about sulfur? Or is sulfur 16? 17 could be chlorine and 18 would be argon. So it's not sulfur, it's phosphorus. But now, hey, Lakshika, you should not remove the message. It's okay. Guys, you should also remember it's good to make mistakes in front of a teacher. Never remove it. Okay? Because ultimately this is where I will be able to help you guys. If you ever retract, I will never be able to help you. And now over here, guys, pay attention. So ultimately the group number, first of all, the phosphorus is the key, atomic number is what we know, and this becomes to nitrogen family. So nitrogen family has group number 15. 16 is for oxygen, 17 is for fluorine, and then finally we have group 18 noble gases. So which all options do we have? B or D. Now we're talking about the valence electrons. Nitrogen family has the configuration which is NS2 NP3. This is half filled one, right? This is what we were looking for. So total number of valence electrons comes out to be 5. 6. This is going to be the correct answer, right? This is going to be the correct answer. Correct? Yes or no? That's the correct one. Good, right? Now let's move ahead. Over here, let's move towards the next question. In comparison to the boron, beryllium has. In comparison to the boron, boron is from group 13. Beryllium is an alkaline earth metal. So over here, beryllium, group 2. In comparison to the boron and beryllium, something like oxygen and nitrogen kind of thing is what I think would be there. Priyanshu Yadav, there's no point of simply putting somebody's name in the chat and simply defaming somebody. Look for good things that you can do. Don't come here for defaming anybody. Come here to learn something. Okay, Priyanshu Yadav ji, you are actually having a very prestigious DP, which is the Indian flag. Let's do something proud. Now, pay attention. Over here, come on boys and girls, let me know what the answer should be. So anyhow, you should remember the answer lies in the electronic configuration. Beryllium has 2s2. Over here it has 2s2, 2p1. Boron is going to have ionization energy of boron is going to be lesser than the ionization energy of beryllium, right? So let's see. Lesser nuclear charge and greater first ionization energy, right? Lesser nuclear charge. Who's having lesser nuclear charge? When we're talking about beryllium, it has lesser. When we talk about boron, it has more. Correct? And greater first ionization enthalpy. In comparison to boron, beryllium has lesser nuclear charge. Obviously, the lesser number of protons and higher nuclear ionization enthalpy. So do remember that. It's okay, Priyanshu, don't be sorry. But yeah, let's go for the, let's learn something over here. Now, moving on to the next question, boys and girls, let's go ahead. In general, the properties that decrease and increase down a group in the periodic table respectively are. So what are we talking about? In general, the properties that decrease and increase down the group. Think about it. What all things decreases down the group? Electronegativity, ionization enthalpy, electron gain enthalpy. Such things decrease down the group. Everything which is related to electrons down the group, people, the elements are like, it's okay. We're too big to just cry for an electron. Okay. So something like that. And what is it going to be? Atomic radius increases. We're looking for decreases, right? Electron gain enthalpy and electronegativity, atomic radius and electronegativity. The correct answer to this question, electronegativity decreases, but when we talk about increases down the group, atomic radius, right? Not the B. Guys, when we talk about down the group, what increases? Electron gain enthalpy decreases is what you should know. Remember, I'll do it for you. Okay, so electronegativity decreases, atomic radius increases. Electronegativity decreases, electron enthalpy decreases. Electron gain enthalpy decreases, electronegativity decreases. Atomic radius increases and electronegativity decreases. Guys, first and the foremost thing that you see, atomic radius and electronegativity were there in the two options. Could be the ones, right? Got it? Amazing. Now let's move ahead. Over here, the correct option with respect to the Pauling scale, Pauling electronegativity values of the elements. Ultimately, they're talking about which is more electronegative and which is more electropositive. That's it. What do you think? I'll give you some options. This is belonging to group 16. This is belonging to group 15. Group 13, group 14. Selenium, tellurium. Do they belong to the same group? group 16. Germanium and gallium. Germanium belongs to group 14 and gallium belongs to group 13. You guys have to let me know. First and the foremost thing, if you do not know these groups, you should consider you getting either 0 marks from this question or -4. Nobody is going to be there in the question, in the examination hall to give you these hints. Yes, you heard me right. No, neither the invigilator is going to help you. So guys, you just do have to remember these groups with the respective elements. Do remember that. And I can clearly see Kishore is giving me the correct answer, which is C. Is it correct? No. The correct answer to this question is D. So what are we talking about when we talk about germanium and when we talk about gallium? See, what are we talking about? When across a period, electronegativity increases. Is it increasing? Yes. It's there in the same group. This is, the period is more than the selenium. Down the group, electronegativity decreases. Here it's increasing. Here it went wrong. This is bigger in size, this is smaller in size. Silicon and aluminium. Come on, man. When we go across a period, electronegativity increases, right? So 14 should have more electronegativity. When we talk about 16, it should have more electronegativity, right? But when we are talking about 13 and 14, 14 will have more electronegativity than 13. You got the answer? Everybody, for those who were not able to do it but now know it, let me know in the chat. And now let's talk about something else. And over here, the element with Z120, not yet discovered. Okay? What do you think? With this particular element will be AND or A. What type of group does this particular element should belong to? I mean, not group, category. Transition metal, inner transition metal, that means the D block elements, the F block elements, alkaline earth metal, group 2 element or group 1 element. What do you think? So just giving you some hint. Let's start with helium. Helium, Z value 2, neon, Z value 10, and then argon, Z value 18, and then we have krypton, Z value ultimately 18 and 18, which is going to be 36, and then we have xenon, Z value is going to be, just add 32, which is going to be 18 again, 2 8 8 18, so which is going to be 54, and then we have radon. Now add 32, which is going to be 86, and then again add 32, which is going to be for 118. OG is the one, yeah. I don't remember the symbol. OG, I guess. Z value 11328. Correct. So now this is a noble gas with 118. How many electrons or how many protons are we talking about later? 2 more. After a noble gas, if we add 1 more proton, we talk about group 1 elements. And if we add 1 more electron to that, we talk about group 2 elements. This is going to be a group 2 element, and group 2 elements are known as the alkaline earth metals. And what is going to be the answer? The correct answer to this question is going to be C. Amazing. And now let's move ahead. Which of the following atoms has the highest first ionization energy? First ionization energy should be highest, which means it should resist more. It should not look for, if this electron gets removed, I'll have a stable electronic configuration. No. If it is having highest first ionization energy, that means after the removal of that electron, this particular element is anyhow not getting stable, not much stable. So do think about it. What do you think? Over here, sodium, removal of electron, that becomes neon. When removal of electron happens from potassium, it becomes argon. When it becomes from rubidium, again the noble gas. And when we talk about scandium, see, when we talk about scandium, we have an electronic configuration of scandium like argon. Then we have 3d1, 4s2. When you remove one electron, it gets removed from here, not from 3d. This is the valence shell. Scandium plus becomes argon, 3d1, 4s1. What should scandium do? Because 4s2 was much more stable. This is fully filled subshell. This is half filled subshell. Half filled subshell. Half filled subshell. Half filled subshell. Correct? So do remember this. this is much more stable than 4s1. There's no point of simply removing it, because ultimately not much improvement have been there when it comes to electronic configuration and the stability. Correct? The correct answer to this question is cesium, and Riya, Kishore, Genius Yuva, everybody is correct. And now let's move towards the next one. Which of the following representation the correct order of increasing ionization enthalpy for calcium, barium, sulfur, selenium and argon? Wow. So let's do something. So whenever we talk about calcium, it's in the period number 4, right? Then we have barium somewhere in the same group, and then we have sulfur. Sulfur and calcium, are they in the same period? Are they in the same period? No. So before this we have magnesium, then somewhere here it comes sulfur in the group 16, and now we have argon as well. So argon comes over here itself, something like this, correct? And what's left? We have barium, calcium, sulfur, selenium. So you should remember, after sulfur we get selenium. So this is what we are talking about. Now what do you think? See, if the placements are not going to be correct, then ultimately you do it wrong. Now guys, what do you think? What's going to be the correct answer? So over here, sulfur oxygen group, yes, absolutely correct. We're talking about the increasing ionization enthalpy. So the first and the foremost thing that you should know, that the noble gas will resist the best, and barium is going to resist the least. This is more electronegative positive, and over here this is argon, which is not at all trying to get its electronic configuration bad. So which all options do you have? See, all the options have argon as the argon having a highest first ionization enthalpy. There is just one option which is having barium first. Then we have sulfur, no. Then we have calcium and calcium. What do you think? Barium is over here, which is having the least ionization enthalpy, the most electropositive one, all because of bigger size. The correct answer to this question, C, correct? C. Anyhow, group 2 element, then we are increasing the group, because across a period electronegativity increases, right? What is this? Selenium. Then why selenium is much more electropositive than sulfur? Because down the group electronegativity decreases. Then sulfur is more electronegative, then argon is what we have. Smile in the chat. And now let's move ahead towards the next one. The first ionization potential of sodium is 5.1 eV. First ionization potential, that means if we had to remove one electron from one particular sodium atom, this much energy was utilized. The value of electron gain enthalpy of sodium plus is going to be, so now guys pay attention. When we are trying to snatch away the electron and keep it away, we provided 5.1 eV of energy. So when this electron wants to come back, how much energy is going to be get absorbed? Released. It's again going to be the same, 5.1 eV. But you should remember, as the energy this time is going to get released, ultimately you should remember, because this is going to be the electron gain enthalpy, and electron gain enthalpy is positive, only negative for all the elements except the noble gases. So it is going to be a negative value, and how much is it going to be? Same but negative. 5.1 eV is going to be the correct answer. So do remember this, right? Amazing, no? And now let's move towards the next one. Over here, the increasing order of first ionization enthalpy of elements B, P, S and F, lowest first is what you have to tell. Lowest first, ascending order, first ionization enthalpy. Boron, okay. Then we have phosphorus. Phosphorus belongs to nitrogen family. Then we have oxygen. Sulfur belongs to oxygen family, and yes, fluorine. So ultimately, whenever we talk about the first ionization enthalpy, where do you think it's going to be the toughest part? Where do you think it's going to be which one of them is going to be the toughest? It's going to be fluorine. Between phosphorus and sulfur, it's going to be the same. All because of N2p3 3p3 configuration. And when we talk about the boron, it's going to be having the least one. So now the correct answer to this question, look for which option is having P greater than S. P greater than S. P greater than S. So either it could be this one or either could be this one. But why the hell boron will have more electronegativity than fluorine? Because as we go across a period, electronegativity increases. So fluorine should be more electronegative than boron. Fluorine should be more electronegative than boron. D is the correct answer. Amazing, right? Now let's move ahead, and over here we are absolutely at the end of this class, and this is where you can always ask a doubt whenever you want, how many you want, and ultimately you should remember you will be getting up in return, you'll be getting up high quality video solutions in English as well as Hindi. So do remember this, and apart from this you will be actually getting up assistance with homework as well. Amazing, right? And what you should do is simply, if you have a doubt, go to doubts and solutions, okay, and then simply take a picture or choose from gallery and simply crop it very properly, click it up properly, and crop it properly so that it's readable. All the options, all the hints should be available with this, which is there in the question. And let us know which subject we're talking about: chemistry, biology, physics, mathematics, and then you will be having a solution as well. Okay, it is going to be a video message as well, maybe in Hindi or English, you'll get to know. And do not forget to provide clear images. Do not forget to provide one question at a time. Do not provide multiple questions at a time. It will become hard to know which question should be given more priority as per your whichever you're preparing, as per your doubts. And so also, yes, we're absolutely at the end of this class. Do share, subscribe, and share the session, subscribe to the channel, like this session as well, and we are going to meet again with the next chapter, which is going to start on Wednesday. With this is going to be chemical bonding. So do remember that. Again, in 3 to 4 classes I'll try to wind up chemical bonding. It is going to be very much, the classes are going to be long and informative. Share it amongst your friends. Okay, good night to everybody. Sweet dreams. I hope you actually enjoyed doing a lot of questions with me. Do not forget to follow me on Unacademy as well. For that, you have to download the Unacademy app on iOS and Android devices. And do not forget to use the code LoveGuru, and do give the scholarship tests as well, because those scholarship tests and everything which is there in the link, technically, it's all for you guys, so that you are aware and you are always on the top. Do remember that. Okay? Chalo. All the best. Take care. Stay safe. And good night. Love you all. Bye-bye. Tata.